Welcome to the session. Now we're going to see about the state elimination technique. This is the method used to solve a given finite automata into a regular expression. And so when you look at this transition diagram, so this is our transition table. By using this, we have to draw a transition diagram. So when you have this diagram, we have to eliminate all the intermediate states, and only the final transition diagram should contain the start state and the final state. Since in our transition diagram both the start state and final states are the same, we need to eliminate all the other states. Only P should be left over after all the state elimination. Okay, now the solution here is three intermediate states, namely Q, R, S are eliminated. Okay, eliminated. And the solution to be found here is, we have to have three cases to be found. One is, so we need to first I need to have this S to be eliminated. So P, S, Q. So this is the path we have to eliminate S now. So to eliminate S, to eliminate the state S, P, S, Q and P, S, R, and finally you will have Q, S, R. So the three possible states are to be calculated. Then only we have to eliminate the complete S states. Okay, so then you have this. After this thing, after we finding out these things, we're eliminated the state called S, and we have left over the three states. So again, for the next step, you have to eliminate this Q1 or either Q1, so either Q or R. Okay, and using this scenario, we have to eliminate all the three states except this one, P. Okay, so now we have to look at the first case. So what is our first case here? So my first case is PSQ. So we have to follow that one, and using that one we need to eliminate it. Okay, so the case 1 over here is, so PSQ. So PSQ, so when you look at this picture, P, S, and we'll have Q, right? So PSQ. So PS 0 and S to Q, it's also 0, right, when you looking at the diagram, and there is no Rij. So as per rule 1, so the regular expression R1 equal to Rij plus Qi S closure Pj, right? So there is no Rij, so this is empty, and Qi is 0, and S closure, phi closure, J will be 0. So we'll have this one 0, 0, and this is 0, 0. So this is my R1. Okay, and the second possible case here is, so when you find this PSQ, we have to find QSP, right? So QSP. Okay, so when you see this QSP, so Q to P, it is 0 when you look at the diagram, and Q to S is 1. Okay, so as per rule 1, R2 equal to Rij plus Qi S closure Pj. So here 0 plus Qi is 1, and there is no S closure, which is known as null phi closure, and we'll have phi. So it is always phi. When you multiply with phi, everything will be phi. So my R2 will be 0. Okay, R2 is 0. So after this we'll have this third case in the sense next possible thing is PSR. So when you see this PSR, so P will have this R is over here. When you P to S will have 0, and PSR, when you have this R it will have 1 and it is 0. Okay, so as per rule 1 we have to see R3, which is equal to Rij. So Rij, there is no Rij, plus the same formula will be used, and Qi is 0 and there is no X closure, that is phi closure, and Pj is 1, which is known as 5 plus 0 1, which is known as 0 1. So my R3 will be 0 1. So when you draw this kind of diagram, we need to redraw the diagram each and every state. Okay, for this PSQ, so when after this diagram, so after this one, my diagram will be look like this. See here, P to Q, right? P to Q, it is 0 0. So after eliminating this one, it is 0 0, and we'll have this one for this Q to P. So Q to P, it is 0 only, right? So for this one, P to R, this is 0 1. So these are all after reduction of this one, this regular expression, my diagram will be look like this. Okay, PSR. After this we'll have to find out RSP, right? So which is known as RSP. So for RSP there is no path is available. So there is no path available from the diagram. Okay. So no path available, or no path exists for this one. Okay. So after that we'll have this final one. Final one is QSR, the possible cases here. So which is known as QSR. So when you look this Q, we'll have this S and we'll have this R, which is 1 and this is 1. Okay. So here R4 will be Rij is 5, and actually this is rule 1, right? All are rule 1, rule 1, rule 1, rule 1. So for rule 1, so this is Q1, Qi, and there is no X closure, and Pj is also 1, 5 plus 1 1, which is known as 1 1. This is R4, right? Okay. So after this diagram, it will be like look like this, Q to R. So Q to R will have 1 1. Okay. So now we have to see the individual states, right? Individual state, which is known as P. So we have find this all possible cases. Now we have found out all these possible cases. After this we have to see the self loop PSP and QSQ. So these are the two important cases to be used. Okay, so now we are going to see PSP, QSQ, right? So PSP, so when you have this, right, PSP, so for PS 0 1, so for this the rule 4 will be used, which is known as R equal to R plus SU closure T. So this is rule 4. Since it contains only 2 states, it applies rule 4, and R is 1 plus S 0, and there is no U. By closure, and T is also 5. Now we are getting only 1. So this is known as PSP, you are getting 1, right? So after this diagram, it has to be redrawn like this. So 1, right? PSP, and we'll have this QSQ, so which is QSQ. So when you see this Q, S. So this is 1 and this also 0. Sorry, this is 0. So when you look at this, the formula same rule 4 will be applied since it is 2 states, and we'll have this 1 R equal to R plus. So this is my R5, right? R5, and this is my R6. Yes, U closure T. So there is no R, and S will be 1, and there is no closure, and 0. So which means 1 0, right? R6 equal to 1 0. So after this diagram, we have to redraw this one. So Q, after this one, you have this one 1 0. So we have to redraw this one. So Q, S, Q, right? So after eliminating this, you are getting only 1 0. So this is the redrawal of this particular transition, and this, for this, it is an equivalent one. Okay, so now when you see this kind of all these things, we have found out all the possible cases, and we have eliminated. Now we are completely eliminated the state yes. After this one, I am just saying, after eliminating yes, my diagram will be, so this is P actually, and we'll have this Q. I just eliminated. So we have 4 states. After eliminating S, we have only 3 states, right? Okay, so for P, so you have to refer this one. So PSP, so this is 1 only, right? P to Q, just refer this one. Where is P to Q? So P to Q is 0 0. So this is P to Q. So that's why you have to make this one 0 0. And Q to P is available? Yes. Q to P is 0. So Q to P is 0. So P to R. Now when you see this P to R, you will have 0 1. Right? It is 0 1. And Q to R, you will have 1 1. So 1. After this, we'll have R. Okay. So when you refer this diagram, R contains a self loop which is known as 0. 0. So 0. So after eliminating S, my transition diagram will be look like this. Okay. Now after we find this one, we have to eliminate R. So this will be our second target. So now we are eliminating S. So after eliminating S, you are getting the diagram look like this. Now we are going to eliminate R. So now the possible cases to be found out are to eliminate. Actually, this is case 2, right? This is case 2, and we have found out case 1 so far, right? So this is our case 1. So this is case 1 here. Okay. So now to eliminate R. So the possible cases to be found out here is PRQ, right? PRQ is to be found out, and we'll have this one QRP, and PRP will have QRQ. So these are the possible cases to be eliminated. So when you have this one, right, 4 possible, after 4 possible cases have to be found out, the states eliminated is R. Okay, R will be completely eliminated. So this is the one. So now we are going to see this under combination. So which is we have to do for PRQ, right? So now the combination here is PRQ. So what is PRQ here? So So this is my first case PRQ. So after having this one, after eliminating this S, we are getting like this PRQ. So as per rule 1, we have to use the formula, right? So this is known as R7, right? So R7 equal to, we have Rij Qi S closure Pj. So this is here 0 0 PRQ, right? Zero zero plus Qi, this is 0 1, S closure is 0 and Pj is 1, right? So when you have this 1 0 0 plus 0 1 0 closure 1, so this is my R7. So after this we'll have this one QRP. So we have to find QRP. So Q, R and P, right? So when you redraw this diagram, from Q to R, Q to R will have this 1 1, right? This 1 1, and this is 1 0. And R to P, there is no R to P, but this is 0 over here, and for Q to P you will have this 0. So when you refer this Q to P, this is 0, right? Okay, so when you go for this rule 1, so we'll have Rij is 0 plus Qi is 1 1 and S closure is 0 closure and Pj is 5. So anything when you multiply by 5, you will get 5. So 0 is my R8. So this is my R8. After this, the next combination to be find out here is PRP. So here P, and we have this R, right? So when you, after this one, you have to redraw everything, right? So this is QRP. So Q to P, right? So Q to P you will get 0, and similarly when you have for this diagram P to Q, right? So P to Q, it is going to be 0 0 plus 0 1 0 closure 1. So this is my P to Q, and so PRP. So when you see this PRP, we'll have this is 1, and this will be R, in a sense from P to R we'll have 0 1, right? So 0 1 and R is here is 1. So now by using rule 4, applying rule 4, R9 equal to R plus SU closure T, right? So this is R, this is 1 plus S in this in 0 1 0 closure, so T. So T here we have 5. So next one R9 equal to 1. So this is my rule 9. Okay, and finally you will have QRQ. So when you draw this QRQ, so Q and this is R. So for Q we'll have 1 0, and for R we'll have 0, and Q to R. So Q to R, when you see this Q to R, this is 1 1, right? So 1 1. So again applying the formula rule 4, we'll have R10 equal to 1 0 plus, so this is the formula, R plus SU closure T. So 1 1 0 closure and T you will have 5. So this is 1 0. So R 1 0, which is 1 0. So when you see this R to Q once again, so R to Q, oh it is value, so this is 1, right? So this is 1, then we'll have this is 1. Now I have to rewrite this 1. So this is my R10. Okay. So this is my R10. 1 0 plus 1 1 0 closure 1. Okay. So finally to eliminate, so we have completely eliminate all the things. So by combining all these steps, right, so for to eliminate R, we'll have this one, right? So here we have to redraw this diagram, which is known as P. So for P you will have 1, and for Q will have 1 0 plus 1 1 0 closure 1, right? So we are after eliminating this, after finding out the self loop, we are getting like this. Similarly for this PRP you are getting like this one. So to eliminate R, right? So to eliminate R, now we have to redraw all these, combining all these steps. So P Q, right? So this is PRP, right? So this is 1, and we'll have this P to Q. So when you see this P to Q, 0 0 plus 0 1 0 the closure 1, and for Q, right? Q, we have to make use of this one. See this one, this thing we have to use. So just for self loop we have to 1 0 plus 1 1 0 closure 1, right? To this Q to P. So Q to P, when you look at this Q to P, see here, this is my Q to P, which is known as 0. So 0. Okay, so this is my final one. So here only 2 states are available. Now my only state, I need to find for regular expression for this state only P, called P, right? Now you have to eliminate. So the next step is, so here the regular expression, we have to find a regular expression R11 equal to R plus SU closure T. So this is my regular expression. So this is R1 plus S is 1 0 0 plus 0 1 0 closure 1, U in the sense 1 0 plus 1 1 0 closure 1, the whole closure, and T will be 0. So this is my regular expression. So this is my regular expression, and next step is eliminate Q also, right? So eliminate Q. So when you eliminate it, right, so R equal to, the formula will be R closure. So what is my R now? So R will be my R11. So R11 closure. So this is R12, which is known as R11 1 plus 0 0 plus 0 1 0 closure 1, and 1 0 plus 1 1 0 closure 1, closure 0, and the whole closure. So this is my final regular expression. Now we are eliminating this Q also. After eliminating this, you are getting R12. So this is my R12, right? So this is my final regular expression. Thank you.